vereceksiniz.
Tamam.
Okay, good afternoon. Our guest speaker today is Dr. Haldun Süral from Industrial Engineering Department, and his speech is entitled Introduction to Operations Research. It's going to be a very, very interesting speech, I believe. Haldun Süral is a faculty member at the Industrial Engineering Department, and he received all his BS, MS, and PhD degrees from Middle East Technical University. His work experience includes teaching and research positions at METU, INSET in France, and UW and WLU in Waterloo, Canada. His applied research works range from beer forecasting and supply production distribution network design to restructuring a large humanitarian aid organization and waste management system design. He is a member of the advisory board of OR Spectrum, and he served at the editorial board of Turkish Journal of Industrial Engineering. He is past president of the OR Society of Turkey. His research interests include methodology, modeling, and applications in OR and history of OR in Turkey. Long time ago, when I was a high school student, I had a seminar from Professor Salim Doğrusöz of Industrial Engineering Department in a youth camp of TÜBİTAK at Çanakkale in Tepe. And I still remember the details of that seminar even today, because it was a very charming and interesting seminar. I believe this seminar will have the same effect on you. You will remember this talk after so many years. Now, the stage is yours. Thank you very much for joining us.
Thank you very much. Actually, I started my career starting with the work in Haldun Doğrusöz, like after graduation, and I was hired by the Haldun Doğrusöz to work in the System Science Institute during that time, and since then we're working together. And actually, Haldun Doğrusöz is now like 93 years old, and he has course today, still teaching right now. We are sometimes delivering the courses together, but now this is solo. Anyway, okay, thank you for coming. It might not be the more interesting as much as the Haldun Doğrusöz is telling is that, but I listened several times he spoke, and then possibly there will be many prints that we can see this talk. Okay. Maybe title it is interesting because when we talk about introduction to operations research, like within an hour to introduce a very wide area, it's not simple. What I thought is that like it is quite interesting discipline, because when we talk about the history of the operations research, like it is very well known, because it's just like come into the picture because of a very important mission, and then there is a very strong detailed information about what happened during that time, and then evolved until today. So therefore, like I thought that like if we go back to how the operations research emerged years ago, and then we can see the many features that we still use today, because those fundamentals and the canons of the operations research actually built up during that time. So therefore, like I thought, like maybe not like if I'm going to say that introduction to physics, possibly many people is going to laugh at me, but for the OR, I think this is going to be a valid statement to discuss about the operations research. First of all, the operations research is about the social systems, okay? And even I'm an industrial engineer, but what happens here is that like our domain is the social system. Means that like the human being is always the part of the system itself. This is the important part, okay? Because like if there is that part, it is completely different than the classical engineering approach to the systems. And industrial engineering is really, let's say, connected with the OR methodology, because mainly we use the OR methodology. So like, first of all, I would like to tell you is that like, it aids decision making. What does it mean is that there is a decision maker and there are people trying to support that decision maker to make a better decisions. And then the management means that they're going to be responsible from the operating, running, controlling the system itself, and then the control of the operations, like how are you going to deal with the operations as the naming ones. There are three basic principles which makes the OR that we understood today. First, the application of the scientific method. Like many engineers use scientific method. But there is other part is that interdisciplinarity. The OR is not done on the basis of only one discipline. OR requires like a group of effort in a way that different people that has expertise on that particular area, because we're talking about the social system, means that like you cannot find somebody else, it's only having the entire knowledge about that system. There could be the different specialists, they do have look into the system in a different perspective. So therefore, like when you look at that way, the OR cannot be performed alone. It is not a solo thing that you can do. The other part is that the systems approach. As I told you, like we are dealing with the social systems, and therefore, like any kind of system which incorporates, let's say, social features or incorporates the human, it is going to be the, let's say, focus of the operations research study. Okay. So therefore, like those three principles are quite important, and which all of them is going to make actually OR. But the thing is that, like through the time, like the some features is lost. There are huge discussions in the literature in that sense. But in terms of the super, it's like we are trying to keep this effort as it is to really do this. The birth of the OR is during the Second World War. And you know what happened during that time. And the Nazis was like, especially the Nazis was like the getting into the very deep corners of the Europe. So that like the alliance, like the especially in the time that the issues were discussed is that like there was only the England is a little far from the Nazi attacks, but the entire Europe is almost was like threatened by the Nazi attacks. So what happens here is that like during that time they succeeded to handle two major things. One of them is that like the warplane attacks to the London during the night, it's blocked by that study. The other part is that since the entire Europe was under the occupation of the Nazis, so then only the supply were coming from the United States to the England, because what happens here is that there was no other things that can come to the Europe. So what happens here is that like the U-boats were during that time, like or planes is attacking those convoys in a way that they can cut the supply, because there was no other sources that to keep the fight against the Nazis during that time. And also the OR actually shaped and helped and stopped this also. So therefore like how it is emerged is very fascinating in that way. So that like especially like because the origin is from the Britain, and then this let's say two activity which really helped to win the alliance in the Second World War. In 1940, like every night, the German planes were coming to the London and they spilling the old stuff on top of the London itself. And then there was nothing that can they do. The one part is that like actually the British scientists during that time, they already have the radar equipment. But the thing is that it wasn't used in a particular situation until that time. So it was a very well designed equipment, but when they come to the gun sight, means that where the bottle is occurring, the entire bottle is occurring, so then they couldn't get those, let's say, impact as they needed. So like there was a terrible, terrible situation for the Britain that time. So what happens here is that like they thought that maybe we need to do something else that can be done not in the military, but there should be another support that come from the other side in a way that that can handle the situation. So therefore they try to build up a research team for that. And this person, Patrick Black, is called for a scientific research to deal with this particular issue. How they can stop that attacks, the warplane attacks to London every night. So what I would like to give you very, very brief who is Patrick Black, and he's actually formerly soldier. Joined the army in a very early age, and he studied there. But and also he incorporated the First World War. And what happens here is that after the First World War, then he became a, let's say, full-time student in the university, and he was a very, very actually intelligent person. Actually, he had the Nobel Prize in Physics in 1948, and his work was known before that, and therefore, like the army, because it has an army background, he called him to handle that situation. If you have any questions during my presentation, then you can ask. And when he looked at the situation, he understood that like they have to develop a completely new technique to deal with, or new approach to deal with that situation. So what happens here is that he built up a team, which is very interesting when you look at the composition of the team itself. And there was three physiologists. Like the physiologists are usually, it's the discipline of the biology, and then how the organism of work and the major functions of the organism are explained. And there was two mathematical physicists and the astrophysicist. An army officer, surveyor means that it's going to look at the around and then they'll look at the ground and that type of things is going to be. One physicist and two mathematicians. And then if you are familiar with the radar is related with the actually radio signals. But there is no such person in this group, because they already work on that radar and it wasn't working right now. We don't know the main reason but what happened here is that, let's say here, these are the very, very interesting stuff, like especially the physiologists, because once the planes arrive into London, it is very terrifying situation. So then dealing with a particular issue, possibly those physiologists is helping the people to that group, like how they can handle this stuff. Because this work is done on the gun side. It wasn't like the working on the table. So actually, because of that varieties, and I'm going to show you that there are other additions to the team, it's called Blackett Circus, because from different places, interesting people come together. So what happens here is that the group makes its residence in the gun side. It is important. And they were trying to understand, for instance, when they adjust the radar equipment, how the accuracy of the aiming is changing with respect to the slope. Slope, surface, and the nature of the ground about the gun site. Because what happens here is that, when it is tested in the lab, the radar was so effective there. But when they come to the gun site, it wasn't work that. So what they needed, what they showed that, the equipment locating was very critical, and they do need to reset the equipment itself. So that was the first diagnosis. And then afterwards, they looked for proper location, and then it should be covered by the mats, but it should be the kind of netting where necessary, wire netting. So what happens here is that also the slope of the ground was quite important. They found the most proper slope itself. And during that time, they computed the area of the netting and the optimal size of the mesh, all are found. And then fixed those radar receiver. And then once that system designed that way, it started to work. And it increases the, getting down those planes is increased a lot. And then the Nazi attacks started to stop. So through the time, for instance, they were using that part like the grass grew under those nets because the England is a very humid region. And so they introduced the geese to keep the grass down. And then also they have the goose shelter to look after the geese and so on. So therefore the black circus come in that particular picture. So what we see here is that the different, and I didn't go into the details of what they were doing in terms of technicality, but the most important things over here is that that was a very difficult problem to solve, and it was very important for the winning the war. The second part is that the old world has the kind of science background, but also there were people which is going to help them, like the surveyor or army officer, in a way that they are going to give the features of that activity itself. So therefore, this team, when we look at in total, this team is completely interdisciplinary. And they use the science. And then what happens here is that when you look at that, they were not doing this work on the table, but they were getting there into the gun site and seeing how those officers are working, what the entire operations are performed, which brings the systems approach. It's not like the concentrating on a particular false thing that do not work, but they try to understand the entire operation itself, and they try to change this, redesign. Okay. And after those systems started to work, of course, they start to collect data, and then those, based on the data, scientists started to give some advice to the combatants. And then the combatants were using those advice, and then they were also collecting the data, and then they giving the scientists. And then, so what happens here is that the system was starting working well and in an effective way. Actually, Haldun is always telling that this is the first operations research book. It's written 1957. Churchman, Eckhoff, and Arno. And in their book, they are such listing the 6 steps of operations research project. These are the diagnosis and formulation of the problem, and the construction of the model, deriving a solution from the model, testing the model and the solution, implementing the solution and controlling the solution. When we look at the Blackett's work itself, then we see that all steps are carried out properly. So therefore, this is how operations research principles built during that time. After that, as I told you, there was another issue in a way that, especially after the fall of France, and then the day of the skateboards, and the Nazis had put their U-boats there. The U-boats is like the submarine. So then what they were doing is that by using the submarine, they were attacking those convoys. Like the entire supply was coming from the US during that time. So therefore, to block into those, let's say, convoys was very critical for Nazis. Or to unblock this situation was very important for the Allies itself. What happens here is that, like for doing that, like Allies power were using the planes in a way that, like, I'm going to tell you what happens, but I would like to give you how to figure out is that, like once, let's say, submarine is, let's say, seen on the surface, and then the planes and the pilots, like, patrolling over the sea, was trying to get the position, and then afterwards to send a bomb, taking the, let's say, starting to dive, and then getting the bomb offset and waiting the submarine was going to be killed. Okay? But the thing is that that system was not working. So, like there was like it was very important, and then they do enough material resources, but it wasn't working. And then the Nazi attacks was very successful. So this time again, an OR study started. First of all, they reviewed the operation, and then, like as I told you, like the pilot of patrolling the aircraft detects the surface submarine. This is how it proceeds. Prepares for the exact positions the plane for diving and dive. That charge is dropped and it goes up with no success. So what happens here is that, like during that time, the engineers think that, like that charge should be go off when the depth is 100 feet. So, like when you look at this, that like the biggest ratio it's going to be effective surrounding submarine was in that part. So therefore, like they thought that like this is going to be the good if that that charge is going off at 100 feet. But what happens here is that a team member in the group asked a very interesting question, like, where is the submarine when that charge goes off? Because they were all the time using the 100 feet for getting that charge goes off, but no one was aware of where those submarines are waiting for. So then an investigation starts for answering this question. Then afterwards it is understood that proportion of the submarines at a given depth was the highest at the 25 feet. When we come to the 100, where the depth charge explodes here, and as you can see here, it's like you have very, very rare number of submarines that you can get there. So after, and I should remind you that like during that time, statistics was very new. Like those models, those computations are very, very unique computations and very, very advanced computations during that time. Like how can you get this curve itself? So what happens here is that, and then afterwards they built a mathematical model in a way that like how they, let's say, estimate the probability of kill as a function of the depth setting. Actually, they found that, let's say, as we showed that like mostly the submarines were available at the 25 feet depth, but actually, even the optimal setting was 25 feet, it wasn't technology possible during that time. 35 feet was the possible minimum setting, and then it's arranged that way. And that actually worked well, and then the Nazis cannot stop that convoy, and they were using a lot their submarines. And that too, actually action, first air defense, and then afterwards the sea defense, is actually made the Nazis very, very terrible situation. So there are too much, like these are the major projects. After the success of those projects, actually there was a lot of work in the military regarding the other activities, not only the UK, but also in the US. So like, I'd like to emphasize that like the principles like the systems approach, interdisciplinary team, and the scientific method is the major features, those things that makes what the OR is. Okay, so like after that success in the war, of course, like as you can imagine, like this type of new technique were attractive for the rest of the world itself, especially for the civilian usage. So then this is how let's say, OR became a discipline, not only implement in the military, but the other part of the activities. And the other part is that, let's say, the computers, like the development in the computers is also make the things very important, because like the problem sizes that are solved are very large, so then the computing power was also helping to solve the complex problems in shorter way. So what happens here is that the major or let's say work is that trying to understand the system behavior, and according to that, what you diagnose there, improve the system performance. Any questions? So I would like to give you some codes here from that first book. I like that words here. For instance, no science has ever been born on a specific day. Each science emerges out of the convergence of an increased interest in some class of problems and the development of scientific methods, techniques, and tools which are adequate to solve these problems. OR is no exception. Its roots are old science as the management function. So therefore, like when you look at that perspective, maybe you can extend the OR before First World War II, or before that time, maybe starting to wear those like the first math things, and then the developments in the science can be connected in that way. But this is a little too much, I think. So what happens here is that like much of this work is done using the analytical and the numerical techniques, because like the OR is looking for using the models. Since what you do is that you are working on the system which incorporates the human, so you do not test your design in the real system. You can use models to test the system itself, so therefore the modeling is quite important in the operations research. And then actually the concrete models are very rare, but the conceptual models, especially those are based on the mathematical models, are quite common. Or specialists may work in academia, industry, or public service, teaching, doing research, consulting, implementing the OR models. And they could be the part of one phase of the research, or could be part of the all phases in a particular project. And then they inform the public officials on energy policy, and these are the applications that we know: design and operation of urban emergency systems, healthcare, water resource planning, criminal justice, and the systems that you can think which incorporates the human inside, and then it is going to be attracted by the water. So also like Variety of issues in communication systems can be handled by your people. Computer operations and design, networking, transportation, marketing, finance, inventory planning, manufacturing, service systems, and many other topics like the trying to improve the business productivity. In that particular portion of my talk, I would like to give you some examples. These are the examples from the last year system design project. And what happens here is that, like in the industrial engineering departments, the course which delivered in 2 terms, students work as a group for a company problem. It means that the problem should be coming from the practice, and there was an advisor from the company and 2 faculty advisors, and they start to work that particular problem in a way that at the end of the year, it's a 2-term course, and at the end of the year they design a system that solves the company's particular problem. Okay? So what happens here is that those are changing depending on the customer demand. So what happens here is that these projects are done for years, different formats, of course, as the time goes. But every year there's a conference, national conference on industrial engineering and the operations research. There's a student competition. And those projects that I'm going to show you last year in the first of the 3 of those projects, or the best 3 projects actually, in that competition. So what happens here is that this is about the İş Bankası. It is based on the cash management system. Because what happens here is that when you go to an ATM, and you knew that you're trying to find out money there, this is one of the purposes. But the thing is that how much money that you're going to put there, it's a big decision. Because what they do is that if the money is going to be not used, then it should be put into the place in a way that they can get some interest from there. So the daily, let's say, keeping the money, okay? So therefore, it is, but the one hand is what happens here, there, how much money that you are going to put, because you don't want a customer can come there and they cannot find out the money. This is, in the long term, it's a bad performance indicator. But if you put a lot of money, then in that case you are losing those interests. Okay? So that these are changing with respect to where that ATM is built and what type of functions are provided. So it is actually a little complex problem. And then the project was about how much money, and then when should be shipped, and how much left during night is decided about that project. And it was very nice project. The second one is that this one, one of the very, let's say, well-known company, Unilever, and you knew that they do have different items for, let's say, starting from the makeup material, and then the different perfumes, and then and also there are some cleaning material used in the personal cleaning. So there are different items they do. And what happens here is that in that particular situation, there are, let's say, some customer, let's say, managers, in a way that they come to where those items are sold, and they look at the availability of the items. And if they are available there, means that they are going to do well. But if there are, let's say, some items are not appearing on the shelf, so then it is an important problem. The one difficulty here is very important. There are varieties of the items, and each item has the version of the variety. Okay, so therefore, like it is very difficult, like from which time, how many copies that you're going to put there, and what is going to be the frequency of those delivering to these items. So it incorporates like the very complex problem in the sense that like the demand is changing through the time, but there is a seasonality in this. So that what happens here is that like to design in a particular system in a way that you do not put more than needed there because it is going to increase the, let's say, holding cost. But if you do not put enough item there, then in that case you are going to lose demand. So it is going to be also another cost in the long term. So therefore they try to find out what is the optimal solution there in a way that they can manage the items on the shelves. The other is that this was this project was done together with the Çankaya Belediyesi, and you know that there are two types of waste that we produce. One is that could be used as a, let's say, a game, but there are some parts that we do not use and we try to get rid of that part. So like this part is related with those recoverable waste. Means that like the valuable items in a way that either you recycle or reuse, or you find out different way to put those into the use again. So like what happens here is that maybe, did you notice on the streets there are blue containers, like the people put those separated items in those containers, and then those containers are collected by the special trucks. So what happens here is that this is the, for instance, like if those containers are provided more, and it is known that more people is going to put those, let's say, products, it's going to be returnable. But what happens here is that, like, if you have many containers, the trucks is needed to more stock, and then to manage those containers is also gets money because more crew needed to handle that many those containers. So what happens here is that, like, you have to find a good balance in a way that you are not going to increase the operational logistics cost in a way that, let's say, the number of people it's going to work this, or like the number of containers that you are going to put, and also you are going to get enough material back. Okay? So that project was about this. Okay. I put the operations research timeline, like many people takes a little bit further than the 1900, but I started with the Taylor. Taylor is the guy started the scientific management movement, and it's also accepted the father of the industrial engineering. Anyway, so I started with that. I would like to show you some maybe interesting part. For instance, like maybe like this econometric society foundation, it is like the important, like when it's come out, it is important, and then also like the time 0, 1937, British military application started. So that the other work is that, let's say, 1942 naval operations research, that it is also important. Here, like the linear programming model, this is one of the most exciting, and then the first algorithm that we use, different than the NAT, but in the OR context, so therefore the linear programming model is like developed the solution developed by the Johnson. It's called simplex method. And also, sorry, there is another one. The people started to deliver the courses about OR. Okay, so this one is interesting. First Operations Research Journal came out in 1950. The other part is that, so like as I told you, like the development of the computer was quite important, like the solving the larger problems, like the many computation that the art people is doing, it is not possible, if it is a meaningful problem, it is not possible to do that by doing manually. You need two computers. So that's 4. The other part is that the first OR journal in US, the Operations Research Society of America founded. Okay, so then this Operations Research Society in England. Here, like the first OR book, 1957, I mentioned to you. Here, like there are some important things, but the most important part here is the International Federation of the Operations Research Society. And as you can see is that how short time like the OR is widespread, like in every country almost it started to put this program in some part of the education. Not maybe under the title of the OR, but the OR people, number of the OR people were increasing. There are some good stuff, but maybe more for OR people. Okay. Okay, I'm going to skip those. Okay, come to the little bit Turkey. What happens here is that in Turkey, like it's been in the most of the part of the world itself, in Turkey, OR is also come to the channel of the army. That the first work done in the army itself. So during that time, it's called Harekat Araştırması. But the thing is that was like, by the way, maybe you notice the title, Radar Operational Research. Like this is the title given to that team during that time. And that when it is civilized, and the radar is just dropped, and the operations research came as it is. But the operations, of course, it's the military term, but not that military as the Harekat implies. Okay? So therefore, like the Halim Bey and his friends, and trying to find out a different name, and they come up with the Yöneylem Araştırması. But when they changed this part, during that time, the student movement was quite high, so therefore some people little scared about when they saw this word, like the eylem itself, and also there was direction. Anyway, so first OR groups, 1950 Turkish military OR group, and then the 65 TÜBİTAK OR group, and then 75 Sibera and Metu, where my career started, and OR education, like the graduate program at Department of Math at Metu at the first time, like the 65, 66. And then the Department of Industrial Engineering, 69. Even the Industrial Engineering Department, as I told you, like we have very strong OR background. 75 Operations Research Program at Metu, and still like one of the very, very rare, let's say, OR program in the world in Metu right now, and that you can find very rare. Like, I mean, the people can work on the OR, of course, they can do the PhD on the OR in the different departments, but the OR program, getting the diploma as an OR program is very rare, actually, because it doesn't sell. The Turkish OR Society founded in 1975, and then the Turkish Society Journal came out in 1980. The first OR conference, 1975, and then the 35th of the OR conference is going to be in Metu, actually, in September this year. If you need to learn more, you're welcome. So this is the the conference announcement, and it is going to be related with the natural resources, how we treat them well or terrible. It's going to be discussed during that time. This is the date it's going to start. And that's it. If you have any questions, and you are looking for a little sleepy, I had 3 hours in the morning, and so I'm a little tired too. But I hope I delivered what I want to say today. Yes, please.
I have a question about for example, you have a problem and there are very many variables. I mean, for example, the renewable material things, there are trucks and money, oil, etc. You're trying to find an optimal solution.
Yeah.
I mean, you have a cost function and you want to minimize it. You're taking some optimization techniques, for example. My question is it, I mean, there is also another approach, trial and error approach. Does it really work? I mean, you made some random experiments, thousands times, maybe millions times, and the one that minimizes the cost function would be the solution.
The randomness is that particular situation cannot work because it is like it's a complex problem, not that much complex, because like you can specify the relations among the components. Maybe it looked like there are many components, but actually it is, I mean, there are difficulties, technical difficulties, but the problem is not very, very complex problem actually, because we are working on that type of problems for years. There's a lot of experience, a lot of research on that part. So therefore, like we knew the basics of things. But the most important part is that every problem is different than its domain. Like the waste management system in Ankara, even everything, the numbers are the same. When you go to the Erzurum, it's not going to be the same because the people will use what they're going to, how they approach there, and what is going to be the reaction. This is those specifics is important there. Okay, so like for instance, I work on that type of problems for years. Like the problem looked like very general in one sense, but the other sense is that there are many specifics, makes some solutions, let's say, implementable, makes some solutions like they are just proposed but never used. Okay, so the randomness, like we try to use human intelligence rather than the randomness. In some situation, OR requires some creativity. It's not only the matter of the math. Math is important, but like there could be tiny, tiny details, for instance, for that particular problem. Like that stupid question, if nobody was asking this, maybe it will take time more, and then what we know, we don't know what is going to happen, for instance, if that scenario didn't work. I mean, I couldn't try to think that. Because like the Nazis is going to go and maybe everywhere. Anyway. Any other questions? Did I answer your question?
Thank you very much.
Thank you.
Thank you very much for just giving this very interesting
I hope so.
lecture to us. And I hope everybody enjoyed that. Thanks a lot one more time.